Jutro, živijo. Ja,
Ko bomo štartali ob 8, ko se vsi priklopijo, bom najprej jaz najavil te pa en uvod naredil, pol pa imaš ti čez stvari. Samo tok.
ok, zmenjeno.
Ok, pa se vidimo čez 5 minut.
Se vidimo, čau.
Okay, hello everybody, good morning, and welcome to the second day of our REACH trainings hosted by University of Ljubljana. So yesterday we talked about products and product development, CAD systems, and remote work associated with that. And today's day is going to be focused on manufacturing processes. And we have a slight change of speakers for the morning sessions, so we had to switch the two sessions around, and we'll be starting with CAM systems presented by Damir Grguraš, and later on we'll have a presentation by Professor Franci Pušavec. So we'll just be switching the two around. So Damir comes from the Department of Machining Technology Management from the Laboratory for Machining. Their focus is on the actual technology of machining processes, which means CNC machining and cutting tool life measurement, even machine tool accuracy, with maybe the special area that the laboratory deals with mostly being cryogenic machining. And Damir is a very prolific researcher with lots of papers on the actual manufacturing processes, focusing on cryogenic machining as well as tool life and other topics related to that, as well as a receiver of quite a few awards for innovation lately. So that's I hope will be an interesting presentation for everybody. So I think Damir, it's best if you introduce yourself as well, and the floor is yours. Please go ahead.
Thank you, Rok, for this introduction. For today's session, I prepared some presentation. I will share it now. I think you can see it.
Yeah, it's everything okay.
Okay, perfect. So good morning, and Rok, once again, thank you for this introduction. And yeah, we switched with Professor Pušavec, and now I will present you the CAM systems. But to give you more information, or to widen it a little bit than Rok said, so I'm coming from a laboratory for machining, but in our department there is one more laboratory for quality assurance in machining. So we are mostly focusing on CNC machining, so on different varieties of CNC machining, meaning on milling, drilling, turning, and so on. So for every this process, we are able to figure out the machinability, to tool life, accuracy, and so on. We are also dealing with measurements, with accurate measurements, with specific 3D measurements, and also with 3D scanning, small bits of 3D printing, and also doing some process controls like statistical process controls, statical and dynamical measurements, and also developing some new applications. As Rok mentioned, we are, let's say, famous with the applications of cryogenic machining. So that road was started with liquid nitrogen. Now we are switching to the CO2 and dealing and having a lot of different research on that topic. And also this cryogenic machining is now already in the stage where it can be industry implemented. Okay, so and the last thing that we are doing also the seminars for the industry. So there is yearly, mostly in September every year. Now it's already been like traditional. This year will be traditional, I don't know, 6th or 7th time seminar from the industry. And in that seminar, we are actually trying to connect the industry with the research. So with our work, and we are trying to show them what's new in the research, and vice versa. So we are trying to collect the information from the industry in order to improve our research and improve the collaboration with the industry. And since we are coming from the CNC machining lab, so mostly dealing with the machining, the huge portion of that machining is actually the creating the NC code or the CNC code for that machining. So in order to communicate with the machine, you need the CNC code, and for that you need appropriate CAM program. That's why I'm going to talk about today about CAM programs and CAM systems. And yeah, with this seminar from industry, one part of that is also the CAM talk, the discussion about CAM technology, and I'm happy that I can share in this following I don't know 60 or 90 minutes of my presentation of what is going on this field. So to start, my agenda will be as follows. So I will start with short introduction for what is actually CAM and what is CAM used for, and then I will switch to the subject CAM systems, which this subject we are also having for students, and I will go over the curriculum of this subject, starting with basic info, and then I'll go through lectures and exercises. After that, I will just present what are the objectives once the student is having this subject, and then what are the intended learning outcomes, and how we are teaching what are our learning and teaching methods. After that, maybe the most interesting part for you will be the aftermath. So how you can use this knowledge gained from the subject or gained from this whole CAM systems area in order to get employment, in order to get work. This can be based on the company or can be, I don't know, with some freelance style dealing of work. So stick around for that as well. So to start, what is actually a CAM? So we should go even further back. So let's start with the CAD. You know, with when you have one idea, usually you start with a paper and this idea of some new product. I don't know, here on the right side you can see just a shaft, and that idea you then use a CAD program, which is a computer-aided design program, when you can actually go from paper drawing, 2D drawing into the 3D space, and you can create the whole object. And then once you have this object created in the virtual space, then you need to find the right tools and the right machining operations if you decide to go with a machining products in order to produce it. That's why there is a CAM programs, which are manufacturing programs that can actually create the codes, which can then be used in order to talk with the machine, in order to get this real piece done. And what is more important is the integration of CAD/CAM. That means that once you have like a design in mind and you have created in CAD, you should always think how to integrate the right designs and how to actually design the whole product in order to create then the easiest CAM. You know that if you design one piece in order to have it done by machining, for example in milling, then you know that you cannot have any close loops or any hidden features inside. Otherwise, the 3D printing will be the better options. So that's why you need to always have this in mind, which operation will be this piece done at the end, and how to then think in the design process, in this CAD process, at the end as manufacturing. And one big thing is actually what I already talked about is design for manufacturing. So this, if you integrate CAD and CAM together, you're actually thinking for the manufacturing, and that means that your base of knowledge and is how to create the right manufacturing process should be integrated. So your designing process is always with the state of the mind of manufacturing. That's why when we are talking to the companies and some student goes from the faculty to the company to start working there, even though he will work, he or she will work in I don't know, design department, creating a new products, or research department, development department. They will always start into the production facility, in the manufacturing facility, in order to see all the processes which can be used, and then he or she can have these processes in mind once designing the product. So, and here is one example. What is the real deal then? How you can actually have the whole integration of that knowledge. Here is one case study of using the CAD-CAM combination, as well as some bits of reverse engineering, that means of 3D scanning. So everything starts with 2D sketch. Then from that 2D sketch, you will create 3D part in the CAD program, and from that part you are actually can create the negative, or so-called tool. Sorry, here is in Slovene, I didn't translate it, but the main point is that from this 3D part you can create a negative and a tool. You can then create physically the tool. So this is a step with CAM inside, and create the physical tool in the machining process. And from that you can use injection molding, and you can create your molded part. And once again, then you can have the reverse engineering, or better to say the quality assurance, so to measure different dimensions and the specifics required. So this is just one case study. So now, when we have this better understanding of what is actually CAM, and that we should thinking about CAM and the manufacturing process at the end, we should think about as well as and design and integrate all that together. And now, when we understand that, I think we can now switch to only CAM systems. So, and now I will present you what is the curriculum of our subject. So, starting off with the basic information. CAM systems, as the full name of subject is the full name of the subject, is actually a study program in our research and development program in the second level at the master's degree, and it goes into the production engineering field of study, which is and this program is then in the second year, in the winter semester. And we have to teach about this system, CAM systems, 14 weeks. And in that 15 weeks, I'm sorry, 15 weeks, the students can have 30 hours of lectures and 30 hours of lecture exercises. And they are requested to have around 65 hours of independent work. And since we are university, this will give them 5 credit points. And as you can see here, 30-hour lectures and 15 weeks execution plan. That means that and they will have like 2 hours per week sessions, and exercises will be divided inside these 30 hours as well. But what is actually the main description of that subject is that it's a specialist course in the study of production engineering, which is an elective specialized course in other fields of study. And we have options to learn to teach that study in Slovenian language and as well as in English for Erasmus students that are coming to our faculty. So now when we know that it's a 30-hour program, I will present you the lectures. So it will be 15 lectures, and every lecture is actually moderated in the way that once you finish the first lecture, you are having the basic for the next lecture, and at the end you are actually having the knowledge that you can understand the industry. That's why in the last session, so in our 15th lecture, we are inviting people from the industry in order to present what is then the real cases from the industry. During that 15 lectures or that 15 weeks, there is not weekly, but there is specifically designed a number of exercises in order that when the student gain a lot of knowledge, that means a lot of lectures, for example, 3 or 4 lectures, then these 3 or 4 lectures are merged together into the one exercise where they can actually do something by themselves and try to implement this knowledge into the real case. Starting with the first lecture, the first lecture is then titled Camp Placement, and short of that, really short of that portion of camp placement I already did at the beginning, and it follows introduction of CAD/CAM, and specifically what is CAM and what is importance and potential of CAM. After the first lectures, the student then understand that what I already explained, what is important for the CAM to understand, and they are not yet prepared to know everything about it, but just to have short overview of what is coming. And coming is the second part or the second lecture. Before going for this CAM specific codes, we are focusing on manufacturing process, which is CNC machining. So since we are coming from the CNC machining lab, we then switch our computer-aided manufacturing from different varieties, CAM from 3D printing, CAM from, I don't know, welding, CAM for machining. And that's why we have one course dedicated in order to have a little bit throwback of what is the machining, what are the machine loads. So specifically, we are discussing here about cutting forces and the loading and the cutting tool and workpieces and overall the machining tool. And this is very important for the students to understand that design for manufacturing in mind means that you know all which machine you will use at the end, and as well which material will be used for that specific product. And then you need to understand which cutting forces will appear and how will this affect your process. So in the machining, as you're familiar, we have 3 main cutting forces, which are in the cutting direction, feed direction, and passive. So the force which is perpendicular to other 2, and these 3 main cutting forces are actually resulting into our tool to worn out. And there can be cases that your cutting tools are too high for the cutting tool to withstand it. That means that your tool can break. So and the main cutting forces are actually correlated to the machining parameters you are actually putting in your CAM program, and that means that you cannot go with a lot of too high cutting parameters in order to machine the surface, because you will have too much of cutting forces. Then the third part or the third lecture. What are the steps of CAD/CAM? So we are actually going in depth of how the CAM is produced, and afterwards how the CAM from that CAD can be produced. And then we're actually discussing about all the steps. So how you have the customer order, the idea, which is then translated into the some design program, computer aided design program, and then how this CAD model is equipped with machining operations in order to create to get the CAM done, and to get, as the result of that CAM, to get a specific CNC program for our CNC machine tool. And one huge thing that we are actually discussing here is the role of post processors. And once you have your CAM program, as you can know that every program can be wide used for different applications, but not every machine is the same. That's why we need to have one in between step from CAM. So when preparing our NC code, so that NC code can be used in our CNC machining tool, we need to have this one additional program, which is called post processor. And with that steps, additional steps, we can then adopt the existing CNC program to our existing CNC machine. And this is very important to understand for a student, that because to have only the CAM program, you can prepare a NC code which can be used then for the companies. However, if you don't have a specific post processing for the CNC machine tool which are they having, probably this won't be useful for them. So keep in mind that once you have the CAM program sorted, you should also have the post processor sorted for the specific machine tools. That's why when students are going to the companies, they are usually working for that company in order to prepare the NC code for the CNC machine tools. However, if they decided to go with their own path and with their own company, only offering the NC program solutions to the companies, they are usually then stick to few companies at the same time, and having sorted out the post processors and actually helping externally to that companies, but basically they are actually working for them closely because they're having post processor for that. Then fourth lecture, which is the whole system manufacturing. So the students will find what are the concepts of manufacturing systems, how the machine tool is programmed, control, and what are the relations with that. And here at the bottom, here is just simple G code or N code, NC code for one operation. And actually, at that stage, the students should understand how this concept is then used for specific manufacturing systems. until now, the students had like 4 lectures, and then the 5th lectures are coming on the kinematics of machine tools. And this is one more important thing prior to start with the ANSI code and with the programming. So the whole kinematics of the machine tools is to understand how the what are the axes and kinematics of machine tools. So that means if you have a turning machine or a milling machine, you will understand where is your X, Y, and Z axis and what that means. And how to integrate that initial conditions into the CAM software, because every CNC machine has its own XYZ equals 0 stage, which is home position of that machine, and you should understand where that 0 position of the machine is, and how can you then transfer that home position of the CNC machine into the home position of your workpiece, and then use this home position for programming of your workpiece. And then that means that the specific ANSI code should be then adopted to that. And one big thing before is that the construction of machine tools, how the machine is built, what are the basic elements or the concrete construction of that, because every CNC machine is put on the ground. This ground should be not connected with the other ground in the facility, in order not to transfer the vibrations from the machine or from the surroundings into the machine, which is already correlated is correlated to the machine tools load that I mentioned, with the cutting forces, with the vibrations, and so on. After that, they are learning as well about dynamics. Just short, how the machine tool, this dynamics influences the machining process. They are learning about dynamics of the cutting process, and as well how you can affect the stiffness and damping. And this whole 7 lectures till now are then actually put together into the one whole story, how the CNC machine is built, where is this CNC machine positioned, what are the foundings of that CNC machine, how this affect of the whole dynamic of the process, and how is this then affected to the machine tool loads, or specifically tool wear and cutting forces. And at the end, all of that should be understand in order to create the right, or in order to select the right cutting parameters in order to create the right CAM program. And then once this whole thing is understandable, as you can see, less than half or half of the subject is divided in order to actually get the real foundations in order to understand the G code. So once this is understandable in the first 7 lectures, then this 8th lecture is actually switching to the core of the subject, and which is how to create the ANSI code. And they will start with the really basic steps. So they will learn what are the main codes, what are the some additional codes, how the ANSI program is structured, And to be more direct for you, so every program, CNC program, has its head, some first initial words for the stuff in the program, has its own main program, and then the end of the program. And as you can see here, every cam code, or it has different names. It has cam code, it like a computer aided manufacturing code. It can be NC code, like numerical control code, or CNC code, CNC code, or some of them are actually calling that G code. Why G code? Because you can see here, one, you have sorted the numbering, the lines from N10 and 20. Then you have a lot of G functions inside. Every that G and some number is specific code. And for example, G0 means rapid movement to the X25, Y20, and Z3 millimeters. So in that line, the students understand that when we come to the fourth line in that program, the machine will understand, okay, I have now G0 input, which means I will go as fast as possible to the position 25, 23 millimeters of the position in my coordinate system, or in specific coordinate system. And in that lecture, the students actually some of them first time touching the understanding of first main G codes, or main functions as G1 or G1, G0, and some additional things. And then in the lectures, they are only having like presented that to them, and then the real exercise follows this up, where the students then create their own NC code for the specific, or for the product they want to produce. Then once they understand the specific G codes, the specific CAM programs, they can go for bigger steps. So how actually it's planning of cutting paths. So now you understand what are the options, which code you can use. Then you then in the next lecture, so in this 9th lecture, you then learn how to select the proper and the right way of producing stuff. For example, if you have here the shaft, which already we saw at the beginning, you need to understand this thread at the end should be done at the beginning. Probably not. First, you need to clean the materials around it, because it come in this material come in rods, and then first you will create the shape, and then at the end you will put the thread here. So they are learning how to actually create the right following of different manufacturing or machining steps, and actually they are creating from that planning of the steps. They are creating like so-called technological plan, and based on that and the timing, they can calculate from simple equations. They will then create economical plan as well, and the whole evaluation of this process, because you know that with all the students that in the companies, usually when you are making offer to the other to some request, you're actually making an offer based on your experience and your predictions and calculations, and if you mess the numbers here or in your technological plan, and you mess the timing, for sure you then mess the economical plan. And if you mess it in the right way, so that you charge a little bit more, and still with that little bit more you are still the cheaper option, then this is perfect. But if you mess in the wrong way, and you actually calculate that you can make it that quicker than you can, and then and you will be for sure cheaper than other options, then you have a problem, because you get an offer, you promise them that you will make that piece for X amount of money, and then at the end you cannot produce it, or you can produce it but with a lot of negative on your back. After that, once the student have this whole story of producing the part, we give them information of how then this CAM program is translated to the existing machine, and actually before of that, how this machine is set to the company's floor, and what are the main regulations, how to calibrate the machine tool and everything prior to using using it. And now we are actually having 3 lectures specifically dedicated to 3 main processes, which are turning, milling, drilling, and robot. So in the following 3 lectures, they will learn how to use specific codes and specific procedures in order to prepare the CAM program in 11 lectures specifically for the turning. So first of all, they will learn of basic elements of CAM turning, and then what is the programming procedure, and what are the calculations and simulations for that. Moving on, next week, so in the 12th lecture, they will then upgrade this knowledge to the CAM of milling, the same. So what are the basics, what is the programming procedure, and how it's calculated. So why are we starting, if I go slide back, why are we starting with the turning? Because turning is much easier to understand for the students. They know that they will produce round and symmetrical products, and they have there is less axis on the machine, so there is Z and X axis, and it's easier to understand the movement of the cutting tool. It's easier to understand them, and a lot of these turning machines actually don't require their specific CAM program, but you can have so-called graphical programming on the machine as well. So we are touching with that on this subject as well. But then comes the milling, as I already mentioned. In the milling, you then have this 3D movement of the cutting tool. You have movement in Z, Y, and X directions, and the rotation of the tool. And with that, you can create some different 3D surfaces, and they will actually just see the basic of this movement. Then we actually spice it up a little bit more and going into more into the details, and from this specific 3 axes in, as I mentioned, Z, Y, and X direction, we are adding additional axis in the machine processes. We are adding 4th and 5th axis movement, and how is then CAM changed on that complex shapes, and how you are actually the students are getting the feeling how with additional more and more axes you are actually more and more dependent of the good CAM software, and the number of these lines of the G code, it's actually increasing enormously, and actually they are seeing that, I don't know, from 12, 20, or 30 G lines for the really basic G code to hundreds of these NC code lines for the multi-axis operations. And then at the end, in the lab, we are having, in addition to the turning and milling and multi-axis milling machines, we are having also the robot, and we are using that robot for machining, and they will actually have a dedicated lecture, for that. So how is the programming the robot different than programming, let's say, multi-axis or 5-axis milling machine? So they will learn that with the robots you have 6-axis compared to 5-axis machines, and that every axis can be moved independently, and how to actually synchronize all these axes in order to get it and to get the cam for the robot. They will learn different program types and so on. And I mentioned at the beginning, the last lecture is actually lecture expert from the industry. So every year we are actually collaborating as the research lab with different providers of CAM softwares, for example, CAMWorks, StrudeCam, or and then or Mastercam, and then we are actually in close connection with that guys which are actually researching the new ways of making a CAM program. And actually every year we select one of them which we think that will provide some good expertise from the field, and we give them one lecture, and they have like a free hands in order to make this discussion with the students. It's more or less a two-way discussion. So the expert will come, will present what is new. The students now have some, let's say, fundamental knowledge about this CAM programming, and they will then discuss, maybe tailor it to the specific needs of the students or what they want to know, and so on. So then this lecture usually, from our experience, the 2-hour lecture is at the end not enough, and then we are trying to extend it a little bit more until we have the free lecture room. But yeah, this let's say cherry at the top guest lecture at the ending of this course is really what the students can then implement and have the real experience from the first hand. Okay, now when we know the whole curriculum of this subject, the whole agenda of how the subject is arranged, I think it will now be easier to understand the exercises. And there is not 15 exercises. There are less exercises, but they are requesting more time. So they are not requiring only 2 hours, but they are requiring more hours. And at the end, they are having as well a seminar. They need to create technological and economical plan. And this seminar will take them up to 10 hours of work or even more, because they are actually having the different pieces of work piece, and they have physical model in their hands, and they need to create the whole steps how this is produced. And they are usually in the groups with 2 or 3 students together, and they are actually acting as a company. They are having requirements. You need to create, I don't know, 10 pieces of some kind of product. Just set me the whole technology, the whole economical, the whole time frame, and everything. In the lab, prior to that seminar is usually used for the last few weeks or for the last month of this whole semester. Prior to that, they have laboratory work. So we are starting with the basic of ANSI programming. So they will learn the basics and then implement that in turning, milling, and robotics. So in basic programming, in exercises, actually we will just go through quickly once again what is the ANSI programming and so on, what I already explained. And then we will go in this exercise, we will go over every G code that there is. So you can see here that are the main codes from starting from G0 as rapid positioning up to G99, or there are, and we will go under every of this G code with the students, explain what this G code will do, and we will do the same for this additional codes, which are M codes or ABC till Z codes, and we'll go every of this code together. And after that, in the second part of that exercise, the students will create their own product at the end. So here's an example. They want to have like a keyring, additional like a hanger for the keys, and this it's, I don't know, on the plate. Plate is, I don't know, 80 by 40 millimeters with some few millimeters of thickness, and they have like rough plate. They're having it, let's say, to create the shape on that plate as they wish. And here is one example of this smiley face. So one student actually created, he wanted to have on this key plate, he wanted to have a smile face in order to smile every day. So he created actually the code, and he marked all the points. And just remember, we are having this basic of ANSI programming. They are doing that by hand. So no CAM program yet. They are going line by line together. And to start that, he will mark all the points he need to touch with his cutting tool. And as you can see here, he marked seven different points. So one point is he will make a face. Then second point, he will make an eye, nose, and then the mouth. And these 7 points is he then using with to create a ANSI code. So in order to make that smiley face, the students, based on the main and additional codes that I showed you. So if I go back, so these two codes, he will then choose the selected ones. So he will choose the proper ones he needs, and based on the knowledge he has about how the ANSI code, as already Max explained, had main program and the end of program, he will then create the ANSI code, create all the lines. He will written by hand everything, and create this 25-line ANSI code in that specific case. Then third part of that exercise is that he will go on the machine. So he will use that code, make small adjustments to the specific CNC machine. Here is, in the lab we have one student machine which is used not for research but only for students. So even if they do something, I don't know, stupidly or crashing, there is not such a big deal, and they are actually completely doing that, but by their own. So he will transfer that a handwritten ANSI code into some text file or whatsoever, and then this file he will adopt it for the specific machine. He will make the right tool position and everything, and at the end he will press the start, and he will try to make the smiley face, or in that case I don't have the video of the smiley face, but I think it's elephant. So you can see. So that's the video which was taken by the student. He will create then on this plate, he will create his G code. Maybe I can make it a little bit faster. So that's then the final result, and based on that three-step exercise, so our presentation of basics, the student work of creating the ANSI program, and then at the end physically making that, they have like a first real connection with the CNC machine, and then they have this whole path of idea on the paper to the final product in the hand. They have this feeling at the end, and just building based on that. Further, the things are getting complicated, but they are having this first start, and everything after that, everything is, let's say, the same, but only more specific, more complicated, and more advanced. That's why they are moving on the second exercise in the lab, which is cam turning. They will have like a specific different shape of cylindrical objects. Here you can see two different examples, one here and one here. They can choose which subject or which object they want to create a code, and they will go on the machine, try to graphically program the turning machine, and once the graphic programming and creating of this ANSI code is done, once again, as for the basic ANSI machining here and cam turning, it's the same. So the students will run the ANSI code, and the machine will produce the part, and this part is actually then the same. It can be the students can take this home as well. So I maybe forgot that students are working alone, but always there is a assistant helping them or answering their questions. And what we are trying to do is not to correct every step. We know when they are actually having some I don't know, some wrong codes, or something is wrong. But if we know that this is not crucial for safety or so on, we actually leaving them alone with that fault inside. And when the machine stops, put some error, they then think what is wrong. They will try to correct that, and we are only here to assist, to help. On the other hand, if there is some, I don't know, major fault in the code, that machine will, I don't know, go with rapid movement into the clamping system, I don't know, will then interrupt and say, you have here some major mistake, try to correct that before going to the machine, and that's it. And then the same once they found of this graphical, then we go to the milling machine, and here they are familiar with the programming in CamWorks program, and first time they are using the Cam program and Real, so they have again specific workpiece or specific product they need to make on the machine, and they will use a CamWorks or one of these Cam programs in order to create a ANSI code in order to go on the machine. And the same here, all the work is by the students. We are only here to assist. And then the last real exercise in the lab is be familiar with the robotic machining. With that, we are actually collaborating with the SprutCam program, which we found to be really good for the robotic programming, and so the students focuses on that program in order to create some product as well. I should mention that in this exercise, CAM robot for milling, turning, and basics, the students also learn how to adjust the cutting tools and how to position the workpiece coordinate system correctly. So not only creating the specific ANSI program for robot milling machine or turning machine, they're also learning how to put the coordinate system on the right place on the workpiece for the specific machining operation. And they're also learning what is the best way to clamp the workpiece material that it will stay there, and what is the best way to clamp the tool, what is how this length of the tool is then transferred into the program, that the program knows that your tool is 10 millimeters long or 100 millimeters long and not 150 millimeters long. In every that exercises, they are learning specifically for that application how is this before machining done. And then comes this big homework, this technological plan. And here is one example. So I already showed this picture at the beginning of my presentation. So this is then their homework. They are divided into smaller groups, up to 2 or 3 students, dependent on what is the level of complexity of the requested piece. For example, this normal cylindrical rod here, you can see it was work of few students, and what they are only having or getting as a request. They are only getting this sketch with all the measurements, with which material is used, and how many number of pieces they want. So what is the amount of number of pieces they need to create, and based on that piece of paper they are getting, they then create the whole technological plan. So following the first, from that they are actually using the CAD program in order to create the real CAD model from that drawing. After that, they will actually contact different companies in order to find the right material for that. Here the material is stated as well, but they need to find the right dimension, so that the materials, they need to find what is the pricing for that material, what is the delivery time and everything. And then they need to select the proper CNC machine, and they need to check if this selected CNC machine have all possibilities, or that actually the length of the whole requested product goes into the CNC machine, and that this CNC selected machine can produce this part. Afterwards, they are actually selecting all the materials. So that means I'm sorry, not the materials, all the cutting tools. So they will have this CAD model, and they will then think, okay, which operations should be done first. And as you can see here, they don't start with, I don't know, with the thread. It's not number 1. It's number 5. So it's 5th operation. And based on that operations, so they will create a technological plan. They will mean that for every specific operation, they will find the right tool and the right holder and the right cutting tool for every of that operations. Here I'm only showing you the few operations, but they will do that for every operation that is for that specific required piece. And what their main thing is that they need to reduce the number of tools used. So imagine that if you have 5 operations, if you can do the 3 operations with the same cutting tool, then you don't need 5 cutting tools, but you have only 3 cutting tools. So that's why they need to think, okay, can we use this maybe this this holder on different application with the same cutting tool and cutting holder. Based on that, they are then getting grades because they can make the technological plan, which is perfect, which is everything is by the book. But if they use too much cutting tools, which means it's too expensive, then to buy these cutting tools, this can be then this is not so good as the other group, which created equally good plan, but with lesser tools. And at the end of this technological plan exercise, they need to create, based on that operations, all of operations that here are shown, they need to create a CAM programming. So they will have for every operation they will show how is this done on the real CNC machine. So they are making then this kind of proof that this can be done with this kind of tools and everything. This is the last step, and then they have the final cut. Okay, so the final cut from the end, and with that they actually create the virtual CAM code, which can then, if they are willing, they can make it on the machine as well, but this is not a requirement. So the result then is they will actually come to our lab after the seminar is done. So after the seminar is done, they will come to our lab and present that work to the assistants and professors, and the commission will then try to understand how they think, how they thought when doing that, and if everything is correct, if they can change something. They will follow some questions from the commission and from the students which are listening as well, and final grades are then completed. So that's basically the whole 15 weeks winter semester in that subject. And let's say that main objective after that subject is actually that students acquire the in-depth knowledge of CAM technologies, and that they become familiar with some CAM principles, and that actually they can use that knowledge on creating a CAM solution for complex machining technologies and on specific products, and that they can calculate the machining tools, tool loads, and so on. And so they will actually gain a lot of competences. So they will have ability to communicate and actually to take the risk and try to make things work. So usually at the end they say that this is the real subject where they, in the exercises, they actually take the responsibilities, stand on the machine, and it's not virtual, it's real, and if you crash it, you cannot undo it. So they will actually have this ability to to do that. Learning outcomes, as already mentioned, so they will have, in the lectures, they will have this in-depth theoretical and analytical knowledge. In the exercise, they will have this then practical application of that theoretical and analytical knowledge. And actually, when they are working, what we found is when they are working by themselves in the exercises, then they have much greater ability to critically think and to innovate more critically the new things further. Teaching methods. Just once again, just go through. You know that in our lectures, that the learning methods are slides and presentations, but in the laboratory exercises, they are work with the real machines. There is not so much sitting and listening the presentation, but the students actually, as we say, get their hands dirty. So they are actually working. That's why the subjects or the lectures in these 15 weeks are divided, the whole group together. So the whole, I don't know, 50 or 60 students together. But for the lectures for the exercises, the students are divided into the smaller groups up to 8 students. So 8 students at one time in the lab, and we are trying to divide that 8 students even into the smaller groups. I don't know, 2 to 3 or 4 students maximum is then one group, and this is actually the group that there is working for the exercises. The smallest group are 1 student, so at home. That's the first exercise when they create their own plate for the key holder. So that's that. At first exercises they are alone, and then further they're actually working in the smaller groups. They can actually think at the real company's floor in the production line. They can go through together, maybe think out loud and make the best possible decisions. And now, what is the aftermath? What students can do after this subject, because this is already at the end of their student path. So there is only 1 semester left, and they can then have they are more or less ready to go to the industry. Aftermath is that after our course of these camp systems, you have only proved that you've been part of the course, and you don't have any proof still that you know how to use that program. They assume that you know, but if you want a certificate, you can have it, because at our faculty of we have as well the community of which then creates this kind of courses when you can get the certificate. And after that subject or after that semester is done, you can apply for this course in camp when you have I don't know, 4 or 5 times meeting on the real afternoon. So you see from 16 to 18 o'clock. So you have then the people from the industry actually giving you the information, and then they are following your work. And
8 aerial defense systems and 1 headquarters.
And if you actually meet the requirements of that course, online course, you can then get the real certificate, which can be then used as some additional to your CV or something like that. And what you can do with that certificate, or specifically for that CAM knowledge, the main majority will go to the one company, and they will search for work there, and they will say, okay, I'm interested for creating the CNC program at your company, and that's the common way. I know few students that created or that selected the self-employment path, and they actually go for the CAM program. They bought the CAM program and the specific post-processing, and then they are actually offering one-on-one programming and consulting to the different companies. So what their work is basically is driving from one company to another company physically and offering the solutions. And maybe they are more flexible, they can more arrange their own time, but they are actually using or they are actually having similar work as employed in one company, only the products are maybe more more different. And there is as well the online possibility. I think that this is as well possible, that you actually only offer your consulting or just creating a basic NC programs to the some desired or to some required companies. And but from our experience for that, I think the references are the most that you need to have. So usually creating the NC programs for some specific and complex products, it's without an experience and references, it's not so easy. And if you want to start somewhere, you will actually start to create the support for the NC programming for some easy to do codes, and then you will build your way up. So that was my presentation for today. I hope that you had a good overview and good insight of how we are actually providing this to the students, and that you had information how this can be then used further for the employment. Now, I think we are a little bit ahead of time. I have 15 minutes, but that leaves us more room for the questions. So if you have any questions, just feel free to ask.
Okay, thank you very much, Damir, for the presentation. It shows really what we're doing here with the students within our courses on the machining side of things. So if there are any questions from the audience, just please go ahead, unmute yourselves, or just raise your hand, and we'll give the microphone to you. So just please go ahead.
Good morning.
Morning.
I would like to thank you for this lecture, valuable lecture. I have a couple of questions. The first is, what is the background of the students you admit in the master program? I mean, the course started with the very basic concepts of CAM. Are you assuming that the students, they do not have background of CAM or CAD before? This is the first question.
Yeah, okay, maybe it's better to understand that, to answer that question, and then go back with second question. What do you think, Rok?
Yeah, you may answer this question.
Okay, yeah, so yeah, that's the subject on the master. And prior to that, they had like 3 years of the faculty, and if they are actually selecting the production engineering course, or the whole road, in the first set or in the first 3 years, they actually are familiar with us only at 2 subjects, which is basic of machining and more specific machining operations. So that's 2 subjects. And with that, they only have the knowledge on the machining, but not on the programming. And there are students that were not familiar with either with the basic of machining, because maybe they are coming from the different faculty for the master program to our faculty. And that's why we actually found that it's better to start with the basics and get these basics few hours and then build on that. Because as I said, we are actually a master program, and it's this program allows that you switch from, I don't know, other faculty, I don't know, electrical faculty at the first stage to the second stage master program to our faculty. And maybe you found during your student years that you are not so home and you are not so enjoying with the electrical stuff, and you want to go to the master with the production engineering, with our machining and so on. You have ability to do that, to change your actually student course and everything. And that's why we want to make it at the beginning, to level the base of knowledge of everyone. Maybe some students are advanced of that, so they are maybe bored at first lectures, but then maybe some are underneath of that, they are putting on the same level, and then after this initial lecture, they are having actually the same starting point, which is more fair, and we can build from there up.
Yeah, thank you. My second question is that are you teaching them other languages rather than the manual word programming? I mean, like computer-assisted programming app?
So, as I showed here, we are focusing on the CNC machining operations, and for that you have this G code or specific G codes, and they are familiar with most of them, and then implement this knowledge into the at least 2 programs, which are ChemWorks in our case and SprutChem. In some cases, maybe a little bit of MasterChem as well, but that's it then.
Yeah, thank you very much.
Thank you. There is
there's a question in the chat, which is what's the required background from the point of kinematics, dynamics, control, and planning that is needed in this field? I think it's related both to machine design as well as robotics.
Mm-hmm. Okay, so what is required background? As I mentioned, prior to that Chem Systems program, the students are familiar with us with 2 other subjects, and these subjects should give them all the backgrounds needed for that. And even if they are listening other subjects in that specific semester prior to our subject, they will have enough knowledge of dynamics, kinematics, and everything. It's not required to understand real deeply dynamics, because that's not our field of work. That's other lab are doing. But what is important is that they know that there is dynamics involved, and they are familiar how they will affect. I know if they increase the depth of cut, for example, how this increase this vibration or something. They just need to understand what is happening there. So that's it.
Okay, thank you. And there's another question in chat, which is whether we use our equipment for commercial purposes as well.
Yeah, for sure. So our lab, there is, I would say, three fields of work. One is student field. So the students are using the machine for the exercises. One field is research. So we as a researcher are using the machine for the research study. And the third part, which is related to this question, is to outsourcing. So to offering the companies some solutions for their specific needs.
Okay, we have another one in the chat, which is, are there any exercises on machines with multiple tool heads, multi-heads?
Multi-head machines. So as you can, so let's make a parallel with this subject with the, I don't know, with the chef. So if you have a chef course, you will know what will make a salt, what will make a pepper, and how you will make your food. And at the end of this course, you will be able to create, I don't know, 3 or 4 foods based on that subject. If you can make a, I don't know, a cake, probably not. It will need some additional experience in between. And the same is here. So you will have basics of CAM for turning, CAM for milling, CAM from robot, and basics of hand answer programming. But after that, you are actually dependent on your own in order to get all the tricks and that are needed to be really expert on that field. And that's why the students which are going to the companies after that, they are actually spending some time in the production line. After that, they will start with some less important or less complex programming. They will build their way onto the same thinking as the company do, and they will and then increase complexity in the programming.
Okay, so do we have any further questions? You can just unmute yourselves and ask Damir directly. Okay, so it seems there are no further questions. So first of all, thank you, Damir, for the presentation. And thank you all for attending. I'm going to repost a particular link in the chat. So there's an evaluation that we need to do in terms of the project after the training. So after today, please save this link and fill out the Google form. Just to give us some feedback, which we need for the quality reporting within the reach the project. So there's one more thing that I want to mention, which is that some of you might be coming to Ljubljana in early June, probably. So the dates are not set yet, but you might be able to meet all the speakers when you come here. So you might have the opportunity to ask some questions further down the line as well. So thank you all for attending. We'll be continuing in approximately half an hour with the actually what was supposed to be the morning lecture from Professor Franci Pușaveț. And with this, I want to thank you all for your attendance. And again, thank you, Damir, for your presentation and preparing all of this for us. So thanks.
Thank you. Bye.
Okay, bye.